Okay, so let's look at radicals. So from lesson number 2, just to review square roots and cube roots. All positive numbers have 2 square roots, a positive square root and a negative square root. The positive square root we call the principal square root. And we use this radical symbol to denote our square roots. The square roots of perfect squares are rational numbers. So the square root of 16 could be both positive 4 and negative 4. However, when we write out the square root of 16, we generally only use positive 4. The time when we use positive and negative, a lot of times is when we're dealing with variables. So if I had the square root of x squared, then I would look at the positive and the negative. Square root of non-perfect squares are irrational numbers, which means they do not terminate and they do not repeat. Whereas cubed roots, like I said the other day, a cubed root will only have one principal or one cubed root. So all numbers, positive or negative, will only have one cubed root, and the symbol for cubed root is the radical symbol, but then I have to put a little 3 in there. That 3 is important because it tells me it is the cubed root. If there is no number in there, then it just means it's the square root. Cubed root of a perfect cube is a rational number, just like the square root of a perfect square is a rational number. The cubed root of a non-perfect cube is an irrational number. So the cubed root of 49 is irrational because it doesn't terminate. It just keeps going on indefinitely. So if 4 times 4 is equal to 16, a square root of 16 would be equal to 4, or the square root of 16 equals 4. If 5 times 5 times 5 is 125, we can say the cubed root of 125 is 5. Or symbolically, we can write it as cubed root of 125 equals 5. And we can go beyond cubed roots. If 2 times 2 times 2 times 2 is equal to 16, a fourth root, because there's 4 of them, a fourth root of 16 would be 2. And the way that we would write it is we would still use this radical sign, but instead of putting a 3, we now put a 4. So it's the fourth root. The fourth root of 16 equals 2. So if I took 10 and I multiplied it by itself 6 times, I get 1,000,000. So if I went backwards, I could say a what root?
A sixth root?
Sixth root of 1,000,000 would be 10. If I wanted to write this symbolically, I would use my radical symbol, and I'd put 1,000,000 underneath, and then I would have to put a 6 right here. Please make certain this 6 should be small, and it should almost be shown wedged into the radical. Okay? It can't be written like this, because that means 6 times something. I need it to be kind of wedged into that radical. So the sixth root of 1,000,000 would be equal to 10. So class example number 1 says, let's mentally evaluate where possible using the real number system. So if I was trying to do the square root of 49, what it means, without using a calculator, is can you think of a number that when I multiply it by itself, I get 49?
7.
Because 7 times 7 equals 49. On B, can I take the cube root of a negative number?
Yep.
Yes. Okay? Because it means when I multiply it by itself 3 times, I'll get a negative number. That works. So let's ignore the negative for now, and let's just look at the number 64. Can you think of a number that when I multiply it by itself 3 times, I get 64?
4.
4 times 4 is 16, and 16 times 4 gives me 64. So this would be -4. If I look at C, what does C mean? Yes. So the fourth root of 10,000, which means, can you think of a number that when I multiply it by itself 4 times, I would get 10,000? 10. 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. Okay, I'm going to skip D for a moment because it's a fraction. I'm going to go on to E. Can I take the fourth root of a negative number? Why not, Ty? Because if I multiply something out 4 times, the result will always be positive, whether it's a negative base or a positive base. -2 times -2 is a +4, times -2 is a -8, but when I multiply by that -2 again, I get a +16. So this is not possible. If I look at F, F is 2 times the cubed root of 125. So can you think of a number that when I multiply it by itself 3 times, I would get 125? 5. 5 times 5 is 25, times 5 is 125. So then this would become 2 times 5, which is 10. Now let's go back to this 1/32. With radicals, what I can do is I can split this, or I can separate it. So I can look at it as being the 5th root over 1 and the 5th root over 32. So can you think of a number that if I multiply it by itself 5 times, I get 1? 1. And can you think of a number that if I multiply it by itself 5 times, I get 32?
2.
2, 4, 8,
16.
32. So the 5th root of 1/32 is equal to 1/2. Are you guys done the 1.7 from yesterday? Okay, I think after the 1.7 there was the 1.8 that went directly after that. I'm sorry, let me read this stuff here and see if you know the answer or how you work on these questions. And then I'll come back and I'll go through them. And you need to take a meter stick that's over in the corner and go measure the senior high lunch. Give me a second. So if we look on the next page, we continue our exploration of radicals and how we can use our calculator to find some of these 4th, 5th, and 6th roots. So on your calculator, if you have your calculator on, and if I wanted to find that 4th root of 10,000 that was on the previous page, I'd have to press the number 4 first. Then I would press the math button and it would bring me to this menu screen and I would choose number 5. Now when I do it because of the calculator I have, it changes my 4 and it makes it smaller. On your calculators, it would actually probably look like 4x like that. It wouldn't make it smaller, and that's fine. So then I would type in my 10,000, hit enter, and there's my 10. So if I wanted to do that 5th root of 1/32, the same thing. Press the 5, then the math, and it would be choice number 5. And then I would use my brackets to put in 1 divided by 32. Press enter, and it gives it to me as a decimal, which I could then turn into a fraction if I didn't know what 0.5 was. So with that in mind, I want you to do class examples 2 and 3, and then I will give you the answers for them. So I'll give you a couple minutes to do class example 2 and 3. So what is the fifth root of 1,024? 4. The seventh root of negative 2,187. Negative 3 times the fourth root of 50,625. Negative 45. So the fourth root of 50,625 was 15. Okay? And the cubed root of 216 over 125. 6 over 5. Okay? Evaluate to the nearest hundredth. So these would be considered non-perfect radicals. So this is not a perfect fifth. Square number, cube number, fourth number, fifth number. So what is the fifth root of 125? The sixth root of 0.5. How many hundredths? 89 hundredths. And 2/3 times the fourth root of 1,000. 3.75. Are there any that you want me to show you up on the calculator? Okay. So these symbols, it's a radical symbol. So if I have the square root of 30, the cubed root of 125, the fourth root of 15, the sixth root of 1,000,000, they're all considered radical numbers. Any expression of the form n root x, where n is a natural number, we talked about natural numbers yesterday, they start at 1 and go up, they're called radicals. The little number n is called the index. And that's why we have to make it a little number. So the index tells me what root I'm taking. If it's the cubed root, the fourth root, the fifth root. The only index that we don't write in is the 2 for the square root. And we don't take the first root, because the first root would just be the number itself. There'd be nothing to be gained. And then the number underneath the radical sign is called the radicand. Okay? When the index is even, the radicand has to be positive. I cannot take the fourth root, the square root, the sixth root, the eighth root of a negative number. Because the eighth root of a negative number means a number that when I multiply it by itself 8 times, I get that radicand. There's no way I can take take a number and multiply it by itself an even number of times and get a negative. So that's important to realize. The radicand has to be positive if my index is even. If I don't have an index, we assume that it is an index of 2. And the index is the number of times the radical has to be multiplied by itself to equal the radicand. So the cubed root of 29, it means a number that when I multiply it by itself 3 times, I'm going to get 29. Okay. Identify the index and the radicand in each of the following. So first of all, how would I read this?
The fifth root and 75.
So the 5 becomes the fifth root and then 75. So what is the index?
5.
And the radicand?
75.
Good. How do I read B? Square root of 50, so what's the index?
4.
And the radicand? I can also read this one as root 50. So the square root or root 50 means the same thing. So you're going to hear me say root 50 a lot, or root 2, root whatever, instead of saying square root. And how would I read this one?
5 times cube root of negative 1 over 10.
Okay. 5 times the cube root of negative 1/10. What's the index?
30.
What's the radicand? Negative 1/10. Not sure if I gave you assignment question number 10. Let's grab our calculator. If I take the square root of 9
It's the
and I multiply it by the square root of 4, what do I get? Okay. If I take the square root and open up a set of brackets of 9 times 4, what do I get? I get the same thing. So when I'm multiplying radicals, I can either multiply them, I can find out their roots and multiply them separately, or I can multiply them together and then find out the root of the product. Okay? If I go the square root of 9 divided by the square root of 4, what do you get?
1.5.
Okay? Now, if I do it together, the square root of bracket 9 divided by 4, what do you get? 1.5. So the same thing when I'm dividing. Square root of 9, which is 3, plus the square root of 4, which is 2, equals 5. What's 9 plus 4? 13. And what's the square root of 13? Is it 5? No. So when I'm adding, I cannot push them together. If I subtract, square root of 9 was 3, the square root of 4 was 2. What's 3 minus 2? 1. What's 9 minus 4?
5.
What's the square root of 5? It's not 1. So those were the results from question number 10 in the previous lesson. If I'm multiplying radicals, I can do them separately or I can put them together. If I'm dividing radicals, I can do them separately or I can put them together. If I'm adding and subtracting, I cannot.
They have
So-
to be separate.
They have to be kept separately. I have to calculate them separately. So the product or the quotient of the roots of two numbers is equal to the root or of the product or quotient of the two numbers together. So product and quotient I can put together. Sum and difference I can't. So in general, the square root of a times b is equal to the square root of ab. Or the square root of a divided by the square root of b is the square root of a over b. I did this one when I did the fifth root of 1 over 32. I split them up and did the fifth root of 1 over the fifth root of 32. The condition in here is a and b can't be equal to 0 because then I get 0 and it's just, we don't deal with that. So if I look at class example number 5. The square root of 3 times the square root of 6. Will that be equal to the square root of 18? Yes or no? Can I multiply these two together?
Yep.
And do I get 18?
Yep.
So this is true. Can I divide these two radicands and get the answer?
Yep.
Yes. If I take the square root of 16 and plus 9, is that the same as the square root of 16 plus the square root of 9?
No.
No. 16 plus 9 is 25. Square root of 25 is 5. This is 4 plus 3, which is 7. This is false. Class example number 6 says put this all together. Square root of 8 times the square root of 3 would be the square root of 24. Square root of 7 times 3 would be the square root of
21.
square root of 50 divided by the square root of 10 would be square root of 5. 50 divided by 10. This one you gotta be careful of because I've got the square root of 100. So do this first. What do I get?
10.
So
Square root of 10.
I get the square root of 10 over the square root of 2, which would be
Square root of 5.
square root of 5. Expressed as a product of radicals. How could I take 77, or the square root of 77, and write it as a product of two radicals? What would I get?
11 times 7.
11 times 7. Can I write 7 times 11?
Yep.
Yeah. So then I could split this up, the square root of 11 times the square root of 7. What about 27? 9 and 3. So the square root of 9 times the square root of 3. What about 40?
4 and 10.
Can I do another one?
5 and 8.
Is there any other ones I could do?
2 and 20.
So I could have 3 different products that would represent the square root of 40. Okay, your questions. So 4, 5, 6. 8. For question 9, let's do B, D, F, H, and then 11, 12, and 13.